All right, hello. Welcome to this lecture on other parts of the scientific revolution. We're going to look now at medicine, chemistry, the scientific method, and the growth of scientific societies, and how this is going to eventually lead into the Enlightenment, which is a 18th century phenomenon, mostly in France, but located in other parts of Europe as well. So let's go through more scientists and components of the scientific revolution. Just a refresher from last time. When we look at medicine today, it's important to note that the medical knowledge of the 1600s is still based on information from 1,000 plus years ago from Aristotle, Galen, the Greek physician, and that the human body contains four humors: blood, yellow bile, black bile, and phlegm. And if you get sick, it means you have an imbalance of humors. I might have shown you images. You might have seen images of, during the plague, for example, doctors looking at urine to diagnose disease. And even some people mocking that and saying, "What are you really looking at? You're not going to be able to find disease just by looking at urine." Treatments at this time were very sparse and vague. Usually, you'd go to a medicine man or medicine woman in your village, because again, in Europe, most people are still living in villages on farms at this point. So again, medical knowledge is very bleak and bland and vague and outdated. So let's see how that slowly starts to change in the 1500s. First, scientists of the scientific revolution that focused on medicine would be Paracelsus. Here he is right here. An interesting guy. He's appointed to a city-wide position in Basel, Switzerland in 1527, but he gets into fights and arguments very easily. He's a very vain guy. He thinks very highly of himself, and this forces him to get kicked out of that position. He eventually becomes homeless and is forced to kind of wander around until his death, less than 20 years later. But he's notable because he is one of the scientists in this period to reject Galen, the ancient Greek physician, Aristotle, who kind of had some similar ideas prior to Galen. And he attacked the universities this time, which were very religious and very focused on these ancient medical outdated ideas. He believed in some scientific methodology such as observation and experimentation to see what's really going on inside the human body. Big finding from him. Again, he did some slight experimentation observation. He didn't go as far as these next two guys, but he did discover, or I shouldn't say discover, but theorize that disease is not caused by an imbalance of humors, but by a chemical imbalance in organs, which is much more closer to modern medical knowledge. You can treat these chemical imbalances with chemicals, leading to his idea that when you get sick, you need to treat the sickness with the disease. So whatever's causing the disease, a poison, a germ, which people don't know what germs are until the 1800s in Europe, but whatever is causing disease can also be a part of the cure, which is kind of what we base vaccination around today, right? Typically, for some vaccines, you're given a weakened form of the disease, and that's supposed to prevent you from getting sick, because you're going to be exposed to a weakened version of that disease that your body can then build up antibodies to resist in the future. He did lots of experimentation with this, and sometimes these did not work. So he did earn the nickname the homicide physician, because his actions didn't always help people. Sometimes they hurt people and killed people. So interesting guy. The next guy, Andreas Vesalius, he focused on particle research, which sounds like a more advanced modern thing, but really what we mean is like looking at the small specks that made up human bodies. He did a lot of research with cadavers, and he's one of the first people to really look at the human form and really make realistic diagrams of the human body. This corresponds with the Renaissance, which is going on in the 1500s, right? Starting in the 1400s, it's still going on in the 1500s. So this realism and that we see in the Renaissance spread to the scientific revolution and spread to the medical, the burgeoning medical field and the medical knowledge that existed in this time. His big contribution was the fact that blood vessels originate in the heart, and kind of got us on that path towards a more modern knowledge around the human body. The guy that kind of finishes all this would be William Harvey, English guy. He was the last person to kind of finally pull the last thread of credibility out of Galen's knowledge base and support. He supported Vesalius's idea that blood flow originates in the heart. He said there's only one type of blood, which we know today is not necessarily true. But that was more so of an attack against like the idea of humors and other fluids in the body rather than these four humors. He says there's just one type of blood. He did operate on people who were prisoners, people who were suspected or convicted of murder and treason, and he operated them on alive to prove his scientific facts. So again, these scientists are using observation, experimentation on cadavers, on live people, to prove their medical knowledge. So by the time we get into the 1600s, we kind of know, Europeans know mostly what the human body looks like and kind of how it works, but there's still big discrepancies between then and today. For example, germs are virtually unknown about. Vaccines aren't widespread. There's very little knowledge on the human brain. It's still kind of seen as a mysterious organ. But over time, we see more and more medical discoveries made possible by these gentlemen that kind of push the medical field forward. Quickly looking at chemistry, just two names you might see pop up: Antoine Lavoisier and Robert Boyle, French and English guys. Lavoisier, kind of started this trend of working with chemistry, focusing and moving chemistry from a qualitative or descriptive science to a quantitative or number-based science. He was executed during the French Revolution. And then Robert Boyle, you might remember him from a physics class or a chemistry class. He came up with Boyle's law, obviously. The temperature of a given mass of confined gas is constant, and the product of its pressure and volume is constant too. See, I can read off the slide very easily. You people with more scientific minds might have a little bit more to know or say about Robert Boyle, but that's basically all you need to know for AP Europe. All right, women. This goes to our topic that I've talked about a lot in this course, the querelle de femme, or the women debate, the women question. How important, how necessary are women in society? Should women have an equal place in society? The question that is still popping up. And to the surprise of no one, this has not changed since the last time we looked at it, a couple lectures ago. Women in the 14, 15, 16, 1700s still don't really see major breakthroughs. However, one thing you should note that does change slightly is if you're a rich upper class woman, such as some of the women pictured here, you can maybe get some free time and the ability to study science on your own as a hobby, and perhaps with some of the funds and money from your family, you can use that to support your interests and your knowledge. Some women in this period are able to do that. They're able to break out of the confinements of society and study science in certain ways. Some examples over here: Margaret Cavendish. She came from an aristocratic background, and she debates science and she debates some of these topics with her contemporaries, with male figures, and kind of gets famous for doing so. Maria Merian was an entomologist. If you don't know an entomologist, it's an insect scientist, and she created some beautiful drawings and descriptions of insects using incredibly accurate details and pictures showing the development cycle of insects. This is important because, a little known fact about this period: most people, peasants, most of Europe were poor peasants farming. They believed insects just came out of the mud, out of the ground. They were afraid of mud because it was like a mosquito breeding ground, and mosquitoes can carry disease and things like that in certain parts of Europe. So, they associated mud with insects. Maria Merian, not only kind of helped to disprove that, but she also kind of showed that insects can change, that the caterpillar you see one day could go into a cocoon and come out a butterfly, in a day or two. So really important knowledge that was, again, kind of spearheaded by a woman. And then Maria Winkelmann was an astronomer who kind of worked and to kind of helped put forward some astronomical theories, including heliocentric ideas. However, like many women in this time, she was denied entry into scientific academies, which I'll talk about in a little bit. While science did provide an outlet for some women to gain access to, more academic parts of society and to gain some amounts of respect for their knowledge, for the most part, the science of the scientific revolution mostly just kept keeping women in their place. Men that now had access to, science, quote unquote science sometimes, because it wasn't always scientific, they now had evidence to back up their belief that women should stay in the house taking care of kids. For example, anatomy and medical knowledge now proved, using dissection and work on cadavers and things like that, that women have wide childbearing hips, proving that according to science and God and everything above, that women are supposed to stay at home and be mothers and caretakers of kids. Now these scientists, these men, had evidence saying, "Hey, it's not us just wanting this. It's science. We have science to prove that you should stay at home taking care of kids." One thing I'll talk about too is the tradition and practice of midwifery. A midwife is a woman who basically her job is to help take care of a pregnant mother and her newborn kids to an extent, and help kind of women get through that pregnancy process, especially because these women have lots of knowledge and experience with being pregnant and giving birth and things like that. And as we know today, even today, there's still lots of dangerous circumstances and environments that go into the pregnancy and birthing process. It's not an entirely safe process for women, especially women of color. So midwives served a super important role in society. That being said, as doctors become more of a common thing and we get further away from like medicine men and women and more into this idea of doctors, these male doctors that think they have lots of knowledge, replace these midwives who actually do have knowledge and experience giving birth. So we'll talk more about this later, but again, it's just another example of science being used to kind of push women to the side and get them out of important roles and spaces. All right, last part of the scientific revolution, we're going to look at the scientific method and how science spread across Europe. So last few people we're going to look at today are Rene Descartes, Francis Bacon, and David Hume. These guys kind of took some of this knowledge that we've seen from these scientists who are doing certain things and kind of made it into a methodology that other scientists could use to deduce things and figure things out. The scientific revolution is known for these two words right here: rationalism and empiricism. Empiricism is just basically basing the knowledge that you have on your experience and experimentation. So your world is based upon what you've seen with your eyes, what you've experienced, what you tested out with experimentation. And you can't really have science without some form of empiricism. That being said, rationalism is kind of the overarching idea that you must be rational in logic. You must have some sort of methodology to develop a knowledge base. You can't just think something is true without having some sort of logical reasoning to it, without some sort of experience to it. So they kind of contradict each other, but together, hand in hand, they kind of develop this idea of a scientific method. So let's look at Rene Descartes first. He was alive in the 15 and 1600s. If you think back, I don't know if you'll remember this person, but Queen Christina of Sweden, her father was Gustavus Adolphus, who died in the 30 Years' War. She was a really big scientific mind. Like I just said, women did, if they were in upper parts of the other upper echelons of society, they did have the chance to learn science and study. She asked her father to get Rene Descartes from France to tutor her, and he obliged. So Rene Descartes did go up and tutor her. However, urban legend has it that that maybe cost him his life. She was a very entitled young woman who had a big thirst for knowledge. So she would often call him to tutor her, like in the middle of the night or early mornings. And this is up in Sweden where it's very cold. So some people believe that due to her, incessant need for tutoring and science and knowledge, that in all hours of the day, that she eventually kind of forced him to get sick, get pneumonia, because she had him up at all hours of the day tutoring her in the cold weather of Sweden. He got pneumonia, got sick, and died while he was tutoring her. However, we don't have any proof of that, but it's just kind of an interesting story. Anyway, he does come up with lots of theories and ideas in his lifespan. Prior to his death during the 30 Years' War during the 1600s. In the psychology sense, you could argue he was one of the forefathers of psychology, teaching that course too. I used to speak about him. But one of his big ideas is this idea of Cartesian dualism, the idea that the mind and the body are separate. And we still kind of talk about this in psychology today. When I teach about the brain and things like that, the brain is, arguably the most important organ in our body. How much of what we do, what we feel, think, react to is our own free will? Does our brain really have total say over everything? Can our brain stop us or control us? So there's lots of questions about, how impactful the brain is and how much say it has on our free decisions and decision-making process and things like that. Who's really in charge? Is it us or is it our brain? Am I saying this right now because I want to, or is it because my brain is telling me to say it? And as we know, the brain does lead. The brain is made up of cells and individual actions by neurons. So what's really causing everything to happen? Interesting mind bubble, mind spiral that can make you think about some things. Anyway, Rene Descartes does come up with this idea of deductive reasoning, which is a part of the scientific method, where you come up with a theory, you formulate a hypothesis, you collect data on that hypothesis, you analyze the data, and then based on the data you collect, you either reject the hypothesis and start over, or you accept the hypothesis and maybe change the existing theory. So deductive reasoning is working down from a large pool of data into one specific thing and changing kind of things around. So working things down from a big pool of information to one specific answer. Inductive is more so the opposite, where you start it with one specific fact and you kind of work your way out to maybe brainstorm and kind of come up with many ideas. So the best idea to do something. And that was more so spearheaded by Francis Bacon, another scientist of this period. So we're going to see these two people kind of come together, and someone like Isaac Newton kind of combined both of these ideas from Francis Bacon and his inductive reasoning and Descartes' deductive reasoning to formulate the modern scientific method, where you can kind of use, think scientifically in different ways, whether you start from a general conclusion, work out to, or from a specific example and work your way out to a general conclusion, or work out from a large ranging question, work down to a specific conclusion through a scientific method of, again, collecting data, analyzing data, and seeing if your science is proven right or wrong. David Hume is another name you might see pop up. He says we experience everything through the senses. So again, this is going to go along with the idea of observation, evidence, and empiricism being important. Important note, these scientists were condemned by everyone at certain points, not always and as harshly as people like Galileo, but we are going to see scientists condemned by not just the Catholic Church, but by the Protestant Church. The Protestants were not always fans of science. This does change in both cases. You do have examples of Catholics being strongly pro-science, and you have Protestants being strongly pro-science. But especially in the early days when everyone's incredibly religious, we aren't going to see a lot of science fans if you're an incredibly religious person. But over time, again, this does change. All right, last slide. So what effects does this have on governments? So we are going to see a few things happen. Number one is the growth of scientific societies. We have the English Royal Society in 1662 and the French Royal Academy of Sciences in 1666. Here you see a picture of King Louis, and I believe this is Jean-Baptiste Colbert with a scientist over here. I could be wrong though. just showing off lots of scientific inventions and acknowledgments and things like that, to really show off just how dedicated these people were to science. Why are governments going to become suddenly supportive of science? Well, like I think I've said this before, if you are if you're a king and you want to get an edge over your opponent, over your enemy, over your neighbor, if you have science in your background in a scientific community, you can put them to work developing quicker loading guns or faster bullets or larger, more explosive cannonballs. So having science in your country is going to be of the benefit to you. If you're worried about your economy, if you're a business person, if you're a bourgeoisie, you want to make your business more lucrative, you can maybe use science to do that. You can come up with a cheaper, more efficient way to fertilize your field using chemicals or something like that. So scientists are going to be supported not just by the government, but by businesses and things like that. And they're going to just grow and grow and grow. We're going to see in these scientific communities, we're going to see the development of scientific journals. People are going to publish their work, and as you may know from science class or from AP Psych even, replication is an important part of science. So people are going to publish their work, talk about the experiments they did, then other scientists across Europe are going to try it. So we're going to see this big growing scientific community develop, and this is known as this public sphere. This also is the same public sphere that we talk about when we talk about the Enlightenment. The public sphere is a really important, crucial vocab word. It's something you can apply a lot in this class. But whenever you see scientists test things out, try things out, if they publish it using a printing press or things like that, they can publish it, send it out to other scientists, and this international dialogue of scientists from France to England to the Netherlands to parts of Italy, parts of Germany, Eastern Europe, Russia, they can talk about these ideas, these experiments, and then spread the news and try them themselves and then expand upon them. They can add a little tweak or a little thing using the scientific method to kind of change that science and make it different and keep adding to the knowledge of science. So public sphere is super important. Again, monarchs are super supportive of science, militaries are super supportive, and even businesses are super supportive of science. We're going to see, again, a big difference between scientists and religion in this period. We do see scientists, for the most part, being incredibly religious. Galileo, for example, even though he was persecuted by the Catholic Church, he was still a through and through Catholic. We aren't going to see any of these people really turn away from religion. However, with the growth of science over the years, we do slowly, and along with the Enlightenment contributes as well, we do see the Enlightenment, the scientific revolution slowly contribute to the erosion of the power of the church and the power of religion in general. So that's going to slowly happen over time in this course. One last note, again, when we talk about causes or the context for the scientific revolution, the Renaissance and the Reformation can contribute a bit. I would say, though, if you're talking about the causes for the Enlightenment, which is our next topic, I would stay away from the Reformation specifically. The Reformation didn't really have too much to do with the Enlightenment. You could maybe argue the Renaissance to an extent, but the Reformation and the Enlightenment, while they shared a few minor things, they're incredibly different and unrelated movements. So just a heads up on that. All right, that's it for the scientific revolution. Next time we'll look at the Enlightenment, and I'll see you then.